Okay, in this video, I just wanted to go through the answer key for Chapter 7. So let's go through problem number 1. All right, so I gave you a cubic. This is a cubic function. It's odd, and odd functions start down and then go up. Okay, so that's the pattern for an odd function where the 7 is positive. So that's why I'm saying down, this is your down, and this is your up. Okay, the maximum number of turns is 1 less than the highest power. So since the highest power is 3, the number of turns is 2. Okay, the classification, it's a cubic because it's the highest power is 3. And we call it a polynomial because the number of terms, so 1, 2, 3, 4, is more than 3. So it's just classified as a polynomial. Okay, so that's the first problem. Okay, the next one, let me change colors. The next problem, this is also a cubic. All right, so it's an odd power. Because it's negative, it starts this way and ends that way. So the behavior is up, down. So that's how I got up, down. It's a cubic, so just like this problem, the maximum number of turns will be 1 less than the highest power, so that's 2. It's a cubic trinomial because it's a cubic due to the power, and it has 1, 2, 3 terms. Remember, the terms are separated by addition and subtraction, so it's a trinomial. Okay, so let's go to the next problem. We have n behavior here. I say it's up, up. It's because this is an even power, and that's a positive number, and these functions look like this. Okay, so the n behavior, up, up. And you can check all of these in your graphing calculator. Just adjust your window so that you can see the n behavior. Okay, moving on to the maximum number of turns. Since the power is 4, the maximum number of turns is going to be 3. And this classification, the power is 4, so it's called a quartic. Okay, you need to know all these words. And because there's only 2 terms, 1, 2, it's a binomial. So it's a quartic binomial. Okay, that brings us to the last one. So the last one is also an even power, but this leading coefficient is negative. So it's going to look like this for n behavior. So it's down, down. The maximum number of turns, 1 less than 4, is 3. And this is a power of 4, so it's a quartic. And I have 1, 2, 3 terms, so it's a quartic trinomial. Okay, and that's the first problem. Okay, question number 2 says, given the polynomial in factored form. Okay, so these guys are your factors. What are the x-intercepts? And the x-intercepts are also called roots. And the way you get them is you set each of those 3 factors equal to 0. So I'm anticipating 3 roots. So if I said x plus 3 is 0, then that means that x equals negative 3. Okay, that's how I got the first one. 2x minus 5 equals 0 gives me 2x equals positive 5, and then x equals positive 5 halves. And the last one, x minus 4 is 0, so x is going to equal 4. Okay, you should be able to see this on your graphing calculator also. If you put this equation right here, oops, in your equation editor, which is your y equals, and then look at the graph. Okay, what is the y-intercept? Okay, so let me just erase all of this and tell you how to get the y-intercept. Okay, so by definition, the y-intercept is where the function crosses the y-axis. For it to cross the y-axis, all your x's are going to be 0. So what you're going to have is your first factor becomes just a 3. Your second factor becomes a negative 5. Okay, and your last one becomes a negative 4. That's by setting everything, all the x's to 0. So then just multiply these numbers. Okay, so negative times a negative is going to be positive, so this will be positive. So 3 times 5 is 15, and 5 times 4 is 60. So that's how I got my 60. Okay, what's the maximum number of turns? Okay, when I multiply this out, I'm going to get a cubic, which means it has n is 3. So therefore, number of turns is 1 less at 2. Okay, let's go on to the last page. Okay, problem number 3 has to do with the rational root theorem. Now, the textbook does not go into that, but I went into it in the notes. They do this thing about saying you get some clues, but the rational root theorem lets you figure out what possible roots you could have for your function. Okay, so the way you do it is, these are fractional roots, so a fraction is like p over q, and then it's plus and minus p over q. Then the p are all the factors of your constant term. So factors of 7. So that's just 1 and 7. The q are all the factors of your leading coefficient, your a term. So that's going to be 1, 2, 3, and 6. So then you do all the combinations. So if you put 7 on top of 1, 2, 3, and 6, you get these. If you put 1 on top, which is the other factor of 7, you get all of these, and then you are going to have plus and minus the signs. So those are all the possible roots you could get. Okay, in problem 4 then I said, given the polynomial function from this problem above, using your graphic calculator, find the actual root and take it to the nearest tenth. So when I actually found the root was negative 1.1, which is close to 1/6, negative 1/6, but not quite there. So in this situation, you don't actually have one of the possible roots as an actual root. Now, this is a cubic, but it's a cubic that only has one real root. So because it has to have 3 roots, then 2 of the roots must be imaginary. Okay, so that means that they're not going to cross the x-axis. This still has 3 roots. It only has 1 real root. So that's the actual root that you can see. Okay, now the last thing we did was to go through some information about rational functions. Remember, a rational function is a polynomial over a polynomial. This is a line over a line, actually. This is a quadratic over a quadratic. So it's basically a function over a function. So it's a fraction. So just like the word ratio means, a fraction, rational has that root in it as well. Okay, so to get the x-intercept of either of these rational functions, you're going to set your numerator to 0. But if you have a hole, so where would we have a hole? Well, the hole shows up right here where those guys are exactly the same. So you've got to eliminate the hole first and then set your numerator equal to 0. Okay, so I end up getting the same value for both. Just a coincidence. To get your y-intercept, you're going to set all your x values to 0 and solve. Okay, so let's see what's going to happen here. Setting these to 0, I'm going to be left with this alone. So that's negative 3/2. Setting these to 0 after eliminating my hole, I end up with a negative 3 over a negative 1, which is a positive 3. Okay, so those are your intercepts. Vertical asymptotes. Let me just get rid of some of my drawing here. Okay, when you want to get a vertical asymptote, you always need to look down. So I'm going to say the word down. You're focused right here in the denominator of the rational function. Set that equal to 0 after you've eliminated the holes. Okay, so when I do that, then set the denominator equal to 0 and solve. Your vertical asymptote is where your function cannot go. So this function, you can't have it divide by 0, So the vertical asymptote will be where the 0 happens, and it happens at -1 for this first one, and it happens at +1 for the second one. Okay, so horizontal asymptote. So I'm going to write the word both. So what you're going to do is you're going to look at that and you're going to say, okay, if the powers are the same in the numerator and the denominator. So in this situation, let me erase my work here. In this situation, what I'm seeing is that I will have a linear term over a linear term. The powers are the same. When that's the case, your horizontal asymptote, which is a line that goes this way, so it's going to be a y = line, is going to be the coefficient right here. So the coefficient of that is 1/2, and that's where the 1/2 comes. Okay, in the other, the second rational function b, you're not going to get rid of those right now. Look at the whole thing in its totality. Do you see how it's going to be an x squared over an x squared, and then with other things once you multiply this out? So here again, the power is the same. Take off that coefficient. That's just a 1. Okay, let's continue our discussion of horizontal asymptotes for one more second. What if I had an x over an x squared? That's bottom heavy, so your horizontal asymptote will always be y over 0. Okay, this power is greater than that power, which is just 1. What if instead, so more horizontal asymptote, I had the reverse. I had x squared over x. If it's top heavy, there is no horizontal asymptote. Okay, so that's the story with horizontal asymptotes. You've got three things, three possibilities. Either the powers are balanced and you're going to take off the coefficient of those powers. It is bottom heavy. If that's the case, it's always y = 0. If it's top heavy, there is none. Okay, and the last thing is wholes. So wholes are once you factor, when the factor in the numerator equals the factor in the denominator, that's a whole. So for this first one, there's no identical factors, so therefore there's no whole. Okay, for this next one, these are identical, so therefore set the identical piece equal to 0, so x will equal -3. That's where the whole is. Okay, so that completes this activity.